Hey, glad you made it. Today we're going to be talking about matter in chemistry, and specifically, we're going to work on your benchmark, which is to distinguish between a mixture and a pure substance. So by the end of this lesson, you should have two goals for yourself. You should be able to say, yeah, I can differentiate between pure substances as being either an element or a compound, and I can categorize mixtures as being homogeneous or heterogeneous. So this lesson will talk about what these things are and how we can tell the difference. So let's back up just a bit and talk about matter. Everything on Earth that is not energy is matter. And it's important to remember that matter is anything with mass that takes up space. So when we look at that, matter can be broken down into two groups. It's either pure substances or mixtures. And then from there, we can break those down into two more groups. Pure substances are categorized as either elements or compounds, and mixtures are either heterogeneous mixtures or homogeneous mixtures. Mixtures are pretty easy to categorize because they both have mixtures in the name. So when we talk about pure substances, those are things that are uniform and their composition does not change. So there's two types. You can have elements, which are pure substances, and compounds. And elements are substances that are made out of only one type of atom. So gold is only gold atoms. That's all you're going to find. Helium, there are only helium atoms. Same with sulfur, same with carbon. So in this diamond, it's just carbon atoms. That's all it is. When we talk about compounds, however, this is where you have pure substances again, these elements, which are chemically bound together. So compounds are going to be two or more elements, different elements, chemically combined. So in water, again, you have two hydrogen, which are chemically combined to the one oxygen. Over here, we have a picture of table salt, sodium chloride. You have one sodium ion, which is chemically bound to one chlorine ion. It's important to remember that compounds, they can't be separated by physical means. So we can separate solutions by boiling things, we can melt things. You cannot boil water and separate the hydrogen from the oxygen. You're not going to be able to melt salt and separate the sodium from the chloride. It just doesn't happen. So on this page we have mixtures, and mixtures are different from pure substances because they're two or more pure substances, but they're physically blended. They're not chemically combined. So in a mixture, each substance keeps its original properties and they can be physically separated. And there are two types of mixtures: homogeneous and heterogeneous. And we're going to talk about how those two are different. Homogeneous mixtures or homogeneous mixtures, they look evenly mixed. So even if you were to look at it at the atomic level, they look like they're evenly mixed. And they contain two or more pure substances. Remember, pure substances can be elements or compounds. And they're evenly mixed, but they're not chemically bonded. The other thing you should keep in mind is that homogeneous mixtures are always in one phase. So when we go down here and we look at air, air is a gas. You never have solid air or liquid air. And air is made out of a lot of different pure substances, mostly nitrogen, followed by oxygen, and then 1%, the remaining 1% is things like carbon dioxide, methane, water vapor, krypton, argon. But these are all pure substances. They're all in the phase of gas, and they are all blended to make air, but none of these molecules are chemically combined with the other. Over here, another example is salt water. Salt is made out of two compounds. It's made out of H2O and sodium chloride. Again, both are pure substances, but again, they're blended. They're not chemically bound. So, and the neat thing about salt water is that both the salt and the water, they keep their physical properties. So if you were to try to evaporate salt water, turn it all into a gas, what you would find is that after a time, the water would heat up enough and it would go from liquid to gas, but left behind, you would have the salt crystals. So in doing that, you would have separated the salt from the water, which is an example of physically separating a homogeneous mixture. And for future reference, another name for homogeneous mixtures is solutions. All right, our last type of mixture will be heterogeneous mixtures. And mixtures are things that are not evenly blended. And we come in contact with these every day. So for example, later on this year we'll be looking at rocks and minerals, and down here is a sample of granite. Granite's a type of rock, and it's made out of three minerals: quartz, feldspar, and mica. When you look at this picture of granite, you can see the black and the pink and the white, the three different minerals, but they are not evenly mixed. Right here I have more mica than I do quartz. Over here where it's really pink, I have lots of feldspar, but not a lot of mica. That is not evenly mixed. And they are certainly not chemically bound either. Over here, which will be coming up sooner rather than later, we have a picture of muddy river water. And again, this is another heterogeneous mixture because the water, as it moves, it has a lot of energy and it picks up silt and dirt and sand and small rocks and it carries it. So those things are mixed in the water, but they're not chemically blended. And when this river starts to slow down, those materials that it's carrying will drop out and settle on the bottom. And so again, that mixture will separate. They're not chemically bound, they're not homogeneous, it's not evenly mixed, and it's physically separated. So that's it. That's the overview of pure substances and mixtures. If you have questions or if you want to review things, you can certainly look at pages 452 through 458 in the purple books, Interactions of Matter. Otherwise, I hope it worked.